Hello everybody. Alright, we're in a new trigonometry chapter now. You just got done learning chapter 11, which was about, started off with right triangle trigonometry, then it ended up being just about triangle trigonometry period, alright? Where you were using sines, cosines, and tangents of angles between 0 degrees and 180 degrees to answer several different questions, alright? You learned a little bit about radians, you learned a little bit about degrees, all that kind of stuff. Now, in this chapter, what we're going to be doing is instead of focusing on triangular trigonometry, which is what you would think all trigonometry is, of course, we're going to focus on what's called circular or periodic functions, which will involve trigonometry that goes beyond what you learned in the previous chapter. And in particular, let me kind of define that right now as this. In this video, we're going to continue to use the unit circle, and we're going to use the unit circle to find the sine of theta, cosine theta, and tangent of theta for an angle of theta that's not between 0 and 180 degrees. Now, angles in a triangle are between 0 and 180 degrees, but you can apply trigonometry to angles that are not between 0 and 180. Now, that's if you're talking about degrees, and then similarly, you're going to be working with angles that are not between 0 and not between pi, if we're talking about the corresponding radian measures. Alright, so unit circle. Everything that I'm going to talk to you about in this video is something that truly you need to work on memorizing or learning how can you use what you know in order to quickly determine the types of things that I'll ask you in this video. Alright, and let's remind you of what you already know. Alright, in degrees, these are the angles that we have worked with in the unit circle. We've worked with multiples of 30 and multiples of 45 degrees up to 180 degrees. And as I said earlier, we stopped at 180 degrees before because no angle in a triangle can be as large as 180 degrees, and we're only working with things inside of triangles basically. Alright, but now what we're going to do is we're going to extend beyond 180 degrees. And we're going to do that in two different ways right now. Well, in this video anyway. One of those is we'll look at the angles that are between 180 degrees, halfway around the unit circle, and all the way around the unit circle, 360 degrees. We're still going with increments of 30 and increments of 45 degrees. Now, let's go with the 30 degrees. We've already got 30, 60, 90, 120, 150, and 180 here. And so then that means we'll have 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, all the way up to 360 degrees. Alright, and then the multiples of 45, we've got 45 degrees and 90 degrees, 135 and 180 degrees already. The other multiples of 45 all the way up to 360 would continue with 225 degrees here, and then 270 is also a multiple of 45. Then 315 degrees is 45 degrees after that, and then 360 is also a multiple of 45 degrees. You are now going to need to know the sines and cosines and tangents of all of those things. All those angles between 0 and 360, those specific ones. You're going to use, however, just what you know about the first quadrant in order to be able to determine the sines and cosines of each of those various angle measures. Alright, so let me remind you what you've done up until now again in terms of sines and cosines and tangents. You know the x and y coordinates of each of the points in the unit circle for these angles right here. I'm going to write those now. Remember that for 30 degrees, the x-coordinate or the cosine value was the square root of 3 over 2, and the y-coordinate or the sine value was 1/2. And then for 45 degrees, both the x and y, or cosine and sine values, were square root of 2 over 2. And then for 60 degrees, the cosine of the x-coordinate was 1/2, and the sine or the y-coordinate was the square root of 3 over 2. Now, others that we didn't really use because they weren't that applicable in right triangles were these. you know the coordinates of this point right here have to be 1, 0, because after all, it's a unit circle. The radius here has to be 1. All right, so that's a point 1, 0. Now, you don't find this in any triangle, actually, but that means that you know the cosine of 0 degrees is 1, and the sine of 0 degrees is 0, right? And then similarly, we never actually use the 90-degree angle in the right angle in a right triangle to find sines or cosine values, but you know that the coordinates of this point would have to be 0, 1. All right, again, because it is a radius of 1 for this circle, so 0, 1 makes sense there, meaning that you now know that the cosine of 90 degrees is 0, the x-coordinate, and that the sine of 90 degrees is 1. All right, and then what you did with that was you extended what you knew about the coordinates here in the first quadrant to figure out what the sines and cosine values were, and tangent values, as a matter of fact, in the second quadrant. Remember, these were just reflections of these values in the x-axis, in the y-axis. And so these angles here each had just basically the opposite cosine value of their reflection in the y-axis, right? The cosine of 60 was 1/2, the cosine of 120 was the opposite of that, negative 1/2, although the sines of these supplementary angles, so these reflections of one another in the y-axis, happened to be the same. Y-coordinate here was a square root of 3 over 2, so it was a y-coordinate for 120 degrees, and so the sine of both 120 degrees and 60 degrees was a square root of 3 over 2, right? This you're already familiar with. And I'll go ahead and throw in 180 degrees. You don't have 180 degrees in triangles, so we never talked about this, but the cosine of 180 happens to be negative 1, because that's the x-coordinate at 180 degrees, and the sine of 180 degrees happens to be 0. Okay, well, that's all stuff, for the most part, that you've done before. Now, when we extend to the third and the fourth quadrants here, we're still just going to use reflections to be able to determine what the x and y coordinates for each of these points are. For instance, in the third quadrant, these points are all just reflections in the x-axis of the angles that you had in the second quadrant, right? Meaning that they're going to have the same x-coordinates as the points directly above, but they're going to have the opposite y-coordinates. So here would be the coordinates for 210, 225, and 240. And I'll throw in 270 right now as well. So for instance, 225 degrees, its coordinates would just be based on the fact that it's a reflection in the x-axis for 135 degrees, meaning its x-coordinate will still be negative square root of 2 over 2, because those have the same x-coordinates, but its y-coordinate will be the opposite. It'll be also, it turns out, negative square root of 2 over 2. So there you've got the cosine and the sine for 225 degrees respectively. Similarly, the cosine of 240 would be negative 1/2, the same as the cosine for 120. And its sine value, the sine of 240, would be the negative square root of 3 over 2, which is the opposite of the sine of 120 degrees, because again, they're reflections in the x-axis. Now here, for 270 degrees, the cosine of 270 is 0. And the sine of 270 is negative 1. All right, and then we can either reflect the points in the third quadrant to make the points in the fourth quadrant, or reflect those in the y-axis, or we could take the points in the first quadrant and reflect those in the x-axis to make the points in the fourth quadrant. All right, whichever way you look at it, here's what these coordinates end up being. All right, you can see each of them have a positive x-coordinate or a positive cosine value, and they each have a negative y-coordinate or negative sine value. All right, and you can use the reflections to kind of understand why each of those values is what it is. Okay, so what I need you to be able to do is memorize basically the sine cosines of 0, 30, 45, 60, and 90 degrees. And then be able to use reflections to figure out what the sines and cosines are, and then ultimately tangents of every other angle that I've listed here that's a multiple of 30 or multiple of 45 degrees, all the way up to 360 degrees. Seems challenging, but this portion right here that you've already memorized is enough to do it with. Okay, now let's talk about the same thing but in radians. So far in radians, you've talked about all the angles from 0 to pi. We said there's 2 pi radians going all the way around the circle, so if you go halfway around the circle, you got the pi radians. meaning that 1/4 of the circle was half of that, or pi over 2 radians and so forth. What you're going to need to know in radian measures are all the multiples of pi over 6 and pi over 4. Now, I'm going to go ahead and list those. We've got 1 pi over 6, here's 2 pi over 6, which is pi over 3. Here's 3 pi over 6, which is pi over 2. 4 pi over 6, which simplifies to 2 pi over 3. 5 pi over 6, and 6 pi over 6, or 1. So now we need 7 pi over 6, 8 pi over 6, which simplifies to 4 pi over 3, 9 pi over 6, which simplifies to 3 pi over 2, 10 pi over 6, which is 5 pi over 3 in simplest form, and then 11 pi over 6. And may as well, while we're talking about it, throw in 12 pi over 6, which is really just 2 pi. All right, and then we need to talk about the multiples of pi over 4. We've already got 1 pi over 4. Here's 2 pi over 4. That's what pi over 2 simplifies from. We've got 3 pi over 4. Here's 4 pi over 4. So we need to include 5 pi over 4. You've got 6 pi over 4 there, and then 7 pi over 4. And finally 8 pi over 4, which is really just 2 pi again. Those are the angle measures that you need to know in regards to radians in a unit circle. And they're going to have the same x and y coordinates as their corresponding degree values that you already wrote down in the previous picture, which I'm going to transfer now. Which is a lot to pop on your screen at once, but we've already gone through the rationale for these. For instance, when you're talking about what is the sine of 5 pi over 3 and what's the cosine of 5 pi over 3, well, you would know that the cosine of 5 pi over 3 is 1/2 because you know that it's just a reflection in the x-axis of pi over 3. All right, and you would know that the sine of 5 pi over 3 would have to be the opposite of that because, again, those are reflections in the x-axis. And you would know, for instance, that the cosine of pi is -1, and that the sine of pi is 0, so forth. Now, you really need this picture drawn, and you can use it for a reference when you're doing homework. Of course, you have to be able to recreate this on your own for a quiz or a test. But this is how you're going to determine, say, the sine and cosine and tangent of 11 pi over 6. All right. Well, let's go ahead then and talk about we've kind of already done this, haven't we? Let's get past that. Let's go ahead and see if we can find angles, the sine and cosine and tangent theta, for angles that are between 180 and 360 degrees, and in the corresponding radian measures. Let's say I wanted to find the sine, cosine, and tangent of 330 degrees. Well, let's start with the sine of 330 degrees. And the way we'll find each of these actually is by comparing that 330 degree angle, which we know is right there, with an angle that it corresponds with, preferably in the first or second quadrant. And so that would be 30 degrees if we compared it to something in the first quadrant. And you know the x and y coordinates for 30 degrees are the square root of 3 over 2 and 1/2 respectively. So we can figure out that since 330 degrees is just a reflection of 30 degrees in the x-axis, that it would have the opposite y coordinate, so it would have the opposite sine value of 30 degrees. So the sine of 330 is the opposite of the sine of 30 degrees, which means that it's equal to -1/2. And then the cosine of 330 would have to have the exact same cosine, would have to be exactly the same as the cosine of 30 degrees because the x-coordinate doesn't change when you reflect a point in the x-axis. Now for the tangent of 330 degrees, keep in mind that identity that we've learned before, that the tangent of an angle theta is equal to sine of theta divided by cosine of theta. And so the tangent of 330 would have to be equal to -1/2 over the square root of 3 over 2, the sine of 330 over the cosine of 330, right? Now I'm not going to go through all the simplification for this. I'll just shorthand it. That means it's -1 over the square root of 3, or -square root of 3 over 3. All right, then for 270 degrees. Now it's what we call a quadrantal angle. basically meaning it's on one of the axes here, the x or y axis. Okay, now we're going to compare it with 90 degrees. You can see that those are reflections in the x-axis, right? And so the sine of 270 would equal the opposite of the sine of 90 degrees. They have opposite y coordinates, don't they? Yeah, that's an ugly 90. And so it's going to be equal to -1. The cosine of 270 would be equal to the cosine of 90 degrees because, well, these x-coordinates are exactly the same as one another, aren't they? So it's equal to 0. And then the tangent of 270 would equal the sine of 270 over the cosine of 270. And since you can't divide by 0, that means the tangent of 270 is undefined. Now I'd like you to see if you can do the same thing for angles between pi and 2 pi whenever we're dealing with radian measures. Find the sine, cosine, and tangent of 7 pi over 4 and for 4 pi over 3. Pause the video, try it, then unpause and see the results. Alright, now we're going to, of course, find the angle. Whoops, that's not what I wanted to do. I wanted to highlight. I want to find the angle that 7 pi over 4 corresponds with in either the first or second quadrant. And that happens to be pi over 4. And based on that, then, we can figure out this. Alright, I'll leave out the explanations, but the sine of 7 pi over 4 then would be negative square root of 2 over 2. The cosine of 7 pi over 4 would still be positive square root of 2 over 2. And then the tangent of 7 pi over 4 would be the sine of 7 pi over 4 divided by the cosine of 7 pi over 4. Now that's just a number divided by its opposite, which is going to give you -1. Alright, now for 4 pi over 3, here are the angles that we're comparing. 4 pi over 3, we'll compare it to an angle in the second quadrant, 2 pi over 3. And those angles will, of course, have opposite y coordinates, so the sine of 4 pi over 3 is going to equal negative square root of 3 over 2. They'll have the same x coordinates, so the cosine of 4 pi over 3 is -1/2. And then the tangent will then just simply be the negative square root of 2 over 2 divided by itself. Whoops, I wrote in the wrong values here, didn't I? Sorry. This is wrong. The ones up there are correct. A little better, right? Negative square root of 3 over 2 divided by -1/2 ends up being negative square root of 3 over -1, which is the positive square root of 3. Okay, now we've gone through most of what I need you to know, but it turns out there's one more new type of angle that we need to include. And I don't mean a new way of measuring like as in degrees or radians, but I mean angles that are not between 0 and 180. Negative angle measures. Alright, there can be negative angle measures whenever we're talking about the unit circle. And whenever we have a negative angle measure, it essentially means that we're measuring angles clockwise as opposed to counterclockwise like you have been so far. Now just to illustrate that, here I've got all the positive angles from 0 to 180 labeled. If I want to go with the negative angles, what I'm going to do is I'm going to have the initial side of those angles be the positive x-axis again, but then I'm going to go clockwise around the circle a given number of degrees. So negative 30 degrees would be 30 degrees clockwise from 0. Negative 45 degrees would be 45 degrees clockwise, and so forth. And thus you ought to be able to see that every negative angle measure is simply a reflection in the x-axis of its absolute value. Alright, so negative 30 degrees is just a reflection in the x-axis of positive 30 degrees. Negative 150 degrees is simply a reflection in the x-axis of positive 150 degrees. And that's the fact that you're going to use to find the sine or cosine or tangent of a negative angle. Alright, and well, we're basically going to work on that in these next couple of examples. Here I'm asking you to sketch each angle theta. I didn't put theta in, but sketch each angle theta in standard position. Then find the sine of theta, cosine of theta, and tangent of theta. And let's start with when theta equals negative 210 degrees. Now when I'm sketching the angle in standard position, I want to think about, first of all, where is the terminal side? and I know it's always going to be a reflection in the x-axis of whatever the absolute value of this number is. So if 200, positive 210 would be right here, negative 210 would be right here. Okay, another way of thinking about that is you're going to go 30 degrees past 180, negative 180. So there's 0, there's negative 90, there's negative 180, so there's negative 210. Now the other thing I'd like you to do when you're sketching an angle in standard position is always show the direction that you went. To illustrate the angle measure, we went clockwise 210 degrees. That's what makes that negative 210. Alright, then for the sine, cosine, and tangent of that, I want you to first notice notationally that when you're taking a trig ratio of a negative angle measure, that you've got to put the angle measure in parentheses. Alright, so there's a sine of negative 210 degrees. And you'll think of that as either being the reflection of positive 210 degrees, or maybe you recognize, as I hope you do, that negative 210 degrees corresponds with positive 150. And if you recognize that, then just think about what's the sine and cosine and tangent of 150. And those would be these values. 1/2 and negative square root of 3 over 2 for the sine and cosine values respectively. And then the tangent value of negative 210 would of course be positive 1/2 divided by negative square root of 3 over 2, which you could write as negative 1 over the square root of 3, ultimately, or negative square root of 3 over 3. Alright, then when theta equals negative 45 degrees, go ahead and draw that. It would be a reflection in the x-axis of positive 45 degrees, which would be there. So here then is negative 45 degrees. And show that it was negative by showing the direction that the angle traveled, just like we did before, and how far. Alright, now for the sine, cosine, and tangent. Either compare this angle to a 45 degree angle, well, that'd be right there, right? Or compare it to 315 degrees, which I hope you can see those would be coterminal, meaning their terminal side is exactly in the same place, right? And you know the sines, cosines, and tangents at 315 degrees would be as follows. Right, just look at your unit circles that we've already created in order to figure that out. Alright, no, it's been a long video to this point. We want to go ahead and get in a couple of negative radian measure problems, and then we'll be done. Alright, so let's do the same thing for when theta equals negative pi, and when theta equals negative 7 pi over 4. Alright, for when theta equals negative pi, that happens to be in the same place as when theta is equal to pi, right? It's just that we went clockwise instead of counterclockwise. Alright, now we know the sine of pi and thus negative pi is 0, because that's the y coordinate right here. And then we know the cosine of negative pi is negative 1. And then 0 divided by negative 1 is not undefined, is it? The tangent of both pi and negative pi happens to be 0. Now for negative 7 pi over 4, think about where positive 7 pi over 4 is located, right here. And then just reflect that in the x-axis again. So there's negative 7 pi over 4. And you ought to be able to see that that is coterminal with positive 1 pi over 4. And so that's how you'll find its sine and cosine and tangent values, which are these here, and I trust you can find those using the unit circle again. Alright, great. Took a little bit of time for the explanation, but you now know how to find the sine and cosine and tangent of an angle that's either between 180 and 360, or for a negative angle between 0 and negative 360, or for the corresponding radian measures, you know how to find the sine, cosine, and tangent of anything from pi to 2 pi, as well as anything from 0 to negative 2 pi for the negative angle measures. Thank you very much for your careful attention to this. I would recommend, if this didn't all sink in the first time, that you rewatch parts of the video just to make sure you've got all of this logic in your head, because this is super important. This is stuff IB expects you to know, and that I expect you to know as such. Alright? Thanks everybody. See you next time.